Alright guys, so this is the review slash study guide for the test, and it pretty much tells you exactly where to find everything. You have two questions where you describe end behavior, and you could find that on Tuesday the 12th class opener. So look at your class opener, it'll be exactly like those guys. Again guys, I repeat, everything is described right here. There's going to be 3 graphing questions without a graphing calculator, but the functions are in factored form. That's super easy. Just take a look at homework page 147, or also look at those videos that I posted where we graphed where they were already in factored form. Now this is the one that we could work on right now because I don't tell you to look anywhere. It's actually in the blue books, and we did this in class where we factor questions and then graph them. So let's check that out. We did this in class, page 146, and let's start out by doing number 1 quickly. And of course, you could, if you could factor it, you might as well factor it. It's the easiest way to go. So if you factor it, pull out an x squared, and what's going to be left? There's going to be a x squared minus 4. Okay. Now the x squared minus 4 could be further factored, so your final factored form will be f of x equals x squared parenthesis x plus 2 x minus 2. And on your test tomorrow, I'm going to want to see the factored form like this, and I'm also going to want to see the graph. So how do you graph this thing? Well, you need to find the answers, and if you separate each one of them, x squared equals 0, that's going to give you the answer x equals 0, but it's going to have the multiplicity of 2. X equals 0 with the multiplicity of 2. So there's x-intercept at 0. It's also going to have, if you take a look at this part of it, x plus 2, if you set that equal to 0, the answer is going to be x equals negative 2. And if you look at the next one right here, x minus 2, if you set that equal to 0, the answer is going to be x equals positive 2. So if you put those dots, negative 2 there and positive 2 there, then you'll be able to graph this thing. Of course, how do you graph this thing? You need to once again look at the original and understand what kind of graph it is. What's the degree? Well, the degree is 4. And there it is. Now, it's an even power degree, so it's going to have an end behavior like a quadratic. And of course, the a value is 1. So if the a value is equal to 1, it's positive. And if it has the end behavior of a quadratic, you know it's going to end up here and up here. Kind of like the way a parabola would end up here and up here. I mean, if you want to, you could even put a little arrow up there and a little arrow up here. Okay? Now, from left to right, we need to think about how this answer is. What kind of multiplicity is it? Well, the x equals negative 2, that's a multiplicity of 1. It has no multiplicity. So what does that mean? That it crosses right through it. Okay? Now, it needs to turn back up, and as it's turning back up, we need to decide, is it going to go through it? Is it going to go through it with a squiggly line? That would be a multiplicity of 3. Or is it just going to go up and touch it and then come back down? That would be the multiplicity of 2. And as you can see, the x equals 0 does have a multiplicity of 2, so it's going to have to go up, touch, and then come back down, and then up and go through. And that's how you would finish this graph. Once again, it went through it because it has multiplicity of 1. Right here it has a multiplicity of 2. That's why it only touched. And then it goes through it again because the x value of 2 only has a multiplicity of 1. It doesn't have a multiplicity of 2. Let's move on. The way we did it in class, we did number 3 next. And again, these might be on the test. That's why I made a video. So number 3, how would you go about it? You could do the rational root theorem. Or you could just use factoring by grouping. It's totally up to you. But on the next one, we're going to be forced to use factoring by rational zero theorem or rational root theorem. So on this one, I want to do factoring by grouping. Okay. So what could I pull out of these two terms? I could pull out an x squared, and if I pull out an x squared, what's going to be left? There's going to be a x minus 1 left, okay? And from the second two terms, I could pull out a negative 4. If I pull out a negative 4, I will have an x with a minus 1 left over on the inside, and as you could see, both groups has the binomial x minus 1. So what I want to do is pull out the x minus 1, and if I pull out that x minus 1, what's going to be left over on the inside? You're going to have the x squared minus 4. Of course, you could continue factoring the x squared minus 4, so that's going to give us a final factored form answer of x minus 1, x plus 2, x minus 2. Now, once it's in factored form, it's cake. Why? Because you know that the answer has to be x equals 1. If you set that equal to 0, it equals 1. This has to be x equals negative 2, and this has to be x equals positive 2. So we get those answers, x equals 1, x equals negative 2, and x equals positive 2. All of them only happen once. So there is no multiplicity on these guys. So here's 1, here's negative 2, here's positive 2. Okay? Now, what kind of function is this? The original function is a cubic function. The degree is 3. So the a value is positive 1. So we need to, again, remember what a cubic function looks like. It looks like this, right? So the end behavior is to the bottom left and to the top right. So if we know that the end behavior is down here, and we know that the end behavior is up here, well, we need to do this this curve right through those points, and we need to think of multiplicity. Now, all of these have the multiplicity of 1, so that means that the line's just going to cross right through it, and then right through it, and then right through it. And that's it. That's how you graph it. Let's move on to number 4. Actually, let's not do 4. We didn't do 4 in class, so we're not going to do 4 on the test. Let's jump back to number 2, because that one we will be forced to use rational root theorem. So here we go, number 2. This one, even if we tried to factor by grouping, it wouldn't work. So what I want to do right now is use the rational root theorem, and I'm going to get the factors of the constant. And the factors of the constant are 1 times 6, 2 times 3, and of course 6 times 1. And we need a plus minus in front of each one of those. And we also need the factors of the leading coefficient, but of course the leading coefficient is negative 1, which means that the factors are plus minus 1, which means that it's not going to make a difference. What does that mean? That the actual list of possible rational roots, all right, the actual list of possible answers. So the possible answers are exactly these same numbers, this list of numbers. That's the possible answers. Because if you did take 1 and put it over 1, it's still 1. 2 over 1 is still 2. 3 over 1 is still 3. So that's a list. So what we need to do now is just start guessing, right? Let's pick a number. Let's see if it works. I'm going to try, and let me zoom out. Let's get some space somewhere. I want to go up here to the top. I want to try the number 1, and I'm not sure if it's going to work. Let me try the number 1. And I'm going to put the coefficients of the rest. So I have minus 1, I have 4, I have negative 1, and I have negative 6. Okay? And of course I'm doing synthetic substitution. The negative 1 comes down, and then you have the 1 times negative 1, and that gives you negative 1, and 4 and negative 1 is 3, and 1 times 3 is 3, and it doesn't look like it's going to work out, guys, because, yeah, it doesn't give me 0. So that did not work. Sorry. Okay, so 1 doesn't work. How about we try negative 1? Hopefully that'll work. Let's try a negative 1 inside the box, and we have negative 1, 4, negative 1, and negative 6. Once again, the 1 comes down. That's negative 1. Negative 1 times negative 1 is 1. 4 and 1 is 5. Negative 1 times 5 is negative 5. Negative 1 and negative 5, that's negative 6. Oh yeah, it's looking good. Negative 1 times negative 6 is positive 6. Heck yeah. Awesome. It did work because the output's 0. That means that negative 1 is an answer. Alright? So we want an answer. What is an answer? Well, x equals -1. That's an answer right there, okay? But we need more answers. So what do? We're going to rewrite the polynomial in factored form. So how do I do that? I need to rewrite the factored form so I have x plus 1. So if the answer is -1, you're going to put x plus 1 in there. Then you're going to need a trinomial. And the trinomial, where do you get that from? You get it from the bottom numbers of the synthetic substitution. So I'm going to have a -1x on actually a -1x squared, a positive 5x, and a -6 is my constant. So I really have a -x squared, I have a plus 5x, and I have a -6 at the very end. Now that looks like a quadratic trinomial that I could factor, but my x squared is negative, and I'm not used to having a -x squared. So let me do this. Let me factor out a -1. So I want to put a -1 out here in front of the x plus 1. That way, this quadratic trinomial will now be positive x squared. It'll be minus 5x if I pull out a -1, and a plus 6. Anyhow, now that looks really good. Now I could actually factor that. So let's factor it. What times what is 6 that if I combine together gives me a -5. Well, that'll be a -2 and a -3. -2 times -3 is positive 6. And if I combine them together, it does give me a -5. Let's bring down the -1. Let's bring down the x and the plus 1. And ladies and gentlemen, this is completely factored. So why is that important? Because on tomorrow's test, when I ask you to graph this guy, I want you to give me the factored form of it first. So here's the first part of your answer. 1, x plus 1, x minus 2, x minus 3. That's an answer right there that you're going to write on your answer spot. Actually on this line right here on tomorrow's test. And then you got to graph it. Okay, so what do we know about this thing? Let's go back to the original. It's a cubic. So we know that the original cubic function has an end behavior down here and up here. That's if the a value is positive. But as you could see, the a value is negative. So it's not going to have down here and up here. It's actually going to be up here and down here. So you could just put like a little arrow right here just to give you an idea that the end behavior is up there and down there. And now let's actually put these numbers, the solutions, on the x-axis as x-intercepts. Once again, the three answers that we get from the factored form, from this factored form we get three answers. X equals -1, x equals 2, and x equals 3. So if we go to -1, put a dot right there. If we go to 2, put a dot right there, and 3, put a dot right there. That's where we end up, okay? So maybe this guy over here wasn't, the arrow shouldn't be way out there. But anyway, we do know that from left to right, it's going to be going down. None of these answers have multiplicity, so it is going to just cross right through it. Let me do it in blue. It's going to cross right through that dot, and then it's going to curve back up and cross right through, and then curve back down and cross right through, and that's it. We have graphed, crossing right through it there. Okay, guys, so I hope this helps. Everything else, all the other ones, you could look at that list and it'll tell you where to find those questions. Remember, I use the same exact questions from the homework and from the class openers on this test.